Ready to get started with AI and the latest technologies? Microsoft Reactor provides events, training, and community resources to help developers, entrepreneurs, and startups build on AI technology. Learn more by visiting aka.ms/InfoQ/Reactor.
Hi everyone, my name is Srini Penchikala. I am the lead editor for AI, ML, and data engineering community at the InfoQ website and a podcast host. In this episode, I'll be speaking with Apoorva Joshi, Senior AI Developer Advocate at MongoDB. We will discuss the topic of how to develop software applications that use the large language models or LLMs and how to evaluate these applications. We'll also talk about how to improve the performance of these apps with specific recommendations on what techniques can help make these applications run faster. Hi, Apoorva. Thank you for joining me today. Can you introduce yourself and tell our listeners about your career and what areas have you been focusing recently?
Sure. Yeah. Thanks for having me here, Srini. My first time on the InfoQ podcast. So really excited to be here. So I'm Apoorva. I'm a senior AI developer advocate here at MongoDB. I like to think of myself as a data scientist turned developer advocate. So in my past 6 years or so of working, I was a data scientist working at the intersection of cybersecurity and machine learning. So applying all kinds of machine learning techniques to problems such as malware detection, phishing detection, business email compromise, that kind of stuff in the cybersecurity space. And then about a year or so ago, I switched tracks a little bit and moved into my first role as a developer advocate. I thought it was a pretty natural transition because even in my role as a data scientist, I used to really enjoy writing about my work and sharing it with the community at conferences, webinars, that kind of thing. So in this role, I think I get to do both the things that I enjoy. Like I'm still kind of a data scientist, but I also tend to write and talk a bit more about my work. Another interesting dimension to my work now is also that I get to talk to a lot of customers, which is something I always wanted to do more of, especially in the Gen AI era. It's been really interesting to talk to customers across the board and just hear about the kind of things they're building, what challenges they typically run into. It's a really good experience for me to offer them my expertise, but also learn from them about the latest techniques and such.
Thank you. So definitely with your background as a data scientist and the machine learning engineer, and obviously the developer advocate, working with the customers, you kind of bring the right mixture of skills and expertise that the community really needs at this time, because there is so much value in the generative AI technologies, but there's also a lot of hype.
Yeah.
So I want this podcast to be about what our listeners should be hyped about in AI, not all about the hype about Gen AI, right? So let me first start by setting the context for this discussion with a quick background on language models, right? So large language models or LLMs have been the foundation of Gen AI applications. They play the critical role in developing those apps, right? So we are seeing LLMs being used pretty much everywhere in various business and technology use cases, not only for the end users, like customers, but also for the software engineers in terms of code generation. I mean, we can go on with so many different use cases that are helping the software development lifecycle, and also DevOps engineers, right? So I was talking to a friend and they are using AI agents to automatically upgrade the software on different systems in their company and automatically send the Jira tickets if there are issues. And AI agents are doing all this, right? So they're able to cut down the number of days, number of weeks for this upgrade, the patching process down to like minutes and hours, right? So definitely the sky is the limit there, right?
Yeah.
So yeah, what do you see? Like, what's the current state of LLMs, and what are you seeing in industry, how they're being used, and what kind of you see how they're being applied today?
So I think there's two slightly different questions here, right? One is like, what's the current state of LLMs, and then applications. So to your first point, I've been really excited to see this shift from purely text generation models to models that generate other modalities such as image, audio, and video. And it's been really impressive to see how the quality of these models has improved in the past year alone. Like there's finally benchmarks, and we are actually starting to see applications in the wild that use some of these other modalities. So yeah, really exciting times ahead as these models become more prevalent and find their place in more mainstream applications. And then coming to how LLMs are being applied today, like you said, right? Like agents are the hot thing right now. 2025 is also being touted as the year of AI agents. So definitely seeing that shift in my work as well. So since the past year, we've seen our enterprise customers move from basic RAG early or mid last year to building more advanced RAG applications using slightly more advanced techniques such as hybrid search, parent document retrieval, and all of this to improve the context being passed to LLMs for generation. And then now we are also seeing folks further move on to agents. So frequently hearing things like self-querying retrieval, human-in-the-loop agents, multi-agent architectures, and stuff like that.
Yeah, you've been publishing and advocating about a lot of these topics, especially LLM-based applications, which is the focus of this podcast. We're not going to get too much into the language models itself, but
Yeah.
we'll be talking about how those models are used in applications and how we can optimize those applications, right? So this is for all the software developers out there. Yeah, you've been publishing about and advocating about how to evaluate and improve the LLM application performance. Before we get into the performance side of the discussion, can you talk about like what are the different steps involved in a typical LLM-based application? Because different applications at different organizations may be different in terms of number of steps.
Sure. Yeah. Thinking of the most common elements, right? Like data is the first obvious big one because the LLMs work on some tasks right out of the box, but at most organizations, they want them to work on their own data or like domain specific use case in industries like healthcare, legal. So you need something a bit more than just a powerful language model. That's where data becomes an important piece. And then once you have data and you want language models to use that data to inform their responses, that's where retrieval becomes a huge thing, which is why things have progressed from just simple vector search or semantic search to some of these more advanced techniques like, again, hybrid search, parent document retrieval, self-querying, knowledge graphs. There's just so much on that front as well. Then the LLM is a big piece of it if you're building LLM-based applications. I think one piece that a lot of companies often tend to miss is the monitoring aspect, which is when you put your LLM applications into production, you want to be able to know if there's like regressions, performance degradations, and if your application is not performing the way it should. So monitoring is the other pillar of building LLM applications.
Sounds good. So yeah, once the developers start work on these applications, I think first thing they should probably do is the evaluation of the application, right? What is the scope? What are the benchmarks? Because the metrics like service level agreements, SLAs, and response times can be different for different applications, right? So can you talk about evaluation of LLM based applications, like what the developers should be looking for and what are there any metrics that they should be focusing on?
Yeah, I think anything with respect to LLMs is such a vast area, right? Because they've just opened up the floodgates for being used across multiple different domains and tasks. And evaluation is no different, right? So if you think of traditional ML models, like a classification or regression models, you had like very quantifiable metrics that applied to any use case. Like for classification, you would have like accuracy, precision, recall, or if you were building a regression model, you had mean squared error, that kind of thing. But with LLMs, all that's out of the window. Now, the responses from these models are natural language or an image or like some generated commodity. So the metrics when it comes to LLMs are hard to quantify. So for example, if they're generating a piece of text for a Q&A based application, then metrics like how coherent is the response, how factual is the response, or what is the relevance of the information provided in the response. Like all of these become more important metrics, and these are unfortunately pretty hard to quantify. So there's two techniques that I'm seeing in the space broadly. One is this concept of LLM as a judge. And the premise there is because LLMs are good at identifying patterns and interpreting natural language, they can be also used as an evaluation mechanism for natural language responses. So the idea there is to prompt an LLM on how you want it to go about evaluating responses for your specific task and data set, and then use the LLM to generate like some sort of scoring paradigm on your data. I've also seen organizations that have more advanced data science teams actually putting the time and effort into creating fine-tuned models for evaluation. But yeah, that's typically reserved for teams that have the right expertise and knowledge to build a fine-tuned model, because that's a bit more involved than prompting.
Yes, you mentioned about domain-specific models, right? So do you see, I think this is one of my kind of predictions, that the industry will start moving towards domain-specific language models. Like healthcare would have their own healthcare LLM, and insurance industry will have their own insurance language model, right?
I think that's kind of my prediction too. And coming from niche domain, right? Like I was in cybersecurity. I used to do a lot of that. And this was in the world when BERT was supposed to be a large language model. So a lot of my work was also on fine tuning those language models on cybersecurity specific data. So I think that's going to start happening more and more. And I already see signals for that happening, because let's take the example of natural language to query, right? That's a pretty common thing that folks are trying to do. So I've seen usually if you, with prompting or even something like RAG, you can achieve about, I would say 90 to 95% accuracy or recall on like slightly complicated tasks, but there's like a small set of tasks that are just not possible by just providing the LLM with the right information to generate responses. So for some of those cases, and more importantly, for domain-specific use cases, I think we are going to pretty quickly move towards a world where there's like smaller specialized models, and then maybe an agent that's orchestrating and helping facilitate the communication between all of them.
Yeah, definitely. I think it's very interesting time with not only these domain-specific models taking shape and the RAG techniques, to kind of, now you can use these base models and apply your own data on that. And plus the agents, taking care of a lot of these activities on their own, right? So the automation type of tasks. So definitely that's really good. So yeah, thanks Apoorva for that. So regarding the application performance itself, what are the high level considerations or strategies the team should be looking at, before they jump into optimizing or over optimizing, or what are the performance concerns that you see the teams are running into, and what areas they should be focusing on?
So most times I see teams asking about three things. There's accuracy, latency, and cost. And when I say accuracy, what I really mean is like performance on metrics that apply to a particular business use case. So it might not be accuracy. It might be, I don't know, factualness or relevance. But yeah, you get the drift, right? And because that's how it is, like because there are so many different use cases, it really comes down to first determining what your business cares about, and then coming up with metrics that resonate with that use case. So for example, if you're building a Q&A chatbot, your evaluation parameters would be mainly faithfulness and relevance. But say you're building a content moderation chatbot, then you care more about recall on toxicity and bias, for example. So I think that's the first big step. And improvements here could be, again, depend on what you end up finding are the gaps of the model. So say you're evaluating a RAG system, you would want to evaluate the different components of the system itself first, in addition to like the overall evaluation of the system. So when you think of RAG, right, there's like two components, retrieval and generation. So you want to evaluate the retrieval performance separately to see if your gap lies in the retrieval strategy itself, or do you need a different embedding model? And then you evaluate the generation to see what the gaps on the generation front are, to see what improvements you need to do there. So I think work backwards, like evaluate as many different components of the system as possible to identify the gaps, and then work backwards from there to try out a few different techniques to improve the performance on the accuracy side. Guardrails are an important one to make sure that the LLM is appropriately responding or not responding to sensitive or off-topic questions. In agentic applications, I've seen folks also implement things like self-reflection and critiquing loops to have the LLM reflect and improve upon its own response, or even human-in-the-loop workflows to get human feedback and incorporate that as a strategy to improve the response. And maybe I'll stop there to see if you have any follow-ups.
Yeah, no, that's good actually. So yeah, I think the follow-up is basically we can jump into some of those specific areas of the process. One of the steps, is choosing the right embedding model. Some of these tools come with I was trying out the Spring AI framework the other day. It comes with a default embedding model. So like, what do you see there? Like, are there any specific criteria we should be using to pick one embedding model for one use case versus a different one for a different use case?
So my general thumb rule would be to find a few candidate models and evaluate them for your specific use case and data set. And for text data, my recommendation would be to start from something like the massive text embedding or MTEB benchmark on Hugging Face. It's essentially a leaderboard that shows you how different proprietary and open source embedding models perform on different tasks such as retrieval, classification, and clustering. Also shows you the model size and dimension. So yeah, I would say choose a few and evaluate for performance and say latency if that's a concern for you. And yeah, there's similar ones for multimodal models as well. Until recently, we didn't have good benchmarks for multimodal, but now we have things like MME, which is a pretty good start.
Yeah, can we talk about a little quick about the benchmarks? So like when we are switching these different components of the LLM application, what standard benchmarks we can look at or run to get the results and compare?
So I think benchmarks apply to the models themselves more than anything else, right? Which is why when you're looking to choose models for your specific use case, you take that with a grain of salt because the tasks that are involved in a benchmark. So if you look at the MMLU benchmark, it's mostly a bunch of academic and professional examinations, but that might not necessarily be the task that you are evaluating for, right? So I think benchmarks mostly apply for LLMs, but LLM applications is slightly different.
You said earlier the observability or the monitoring, if you can build that into the application right from the beginning, it will definitely help us pinpoint any performance problems or any latencies.
Exactly.
So another technique is, how the data is divided or chunked into smaller segments, right? You published an article on this. So can you talk about this a little bit more and tell us, what are some of the chunking strategies for implementing the LLM apps?
Sure, yeah. And I think my disclaimer from before, right? Like with LLMs, the answer starts from it depends, and then you kind of like pick and choose based on. I think that's like the thumb rule for anything when it comes to LLMs. Like pick and choose a few, evaluate on your data set and use case, and go from there. So similarly for chunking, depends on your specific data and use case. For most texts, I typically suggest starting with this technique called recursive token with overlap with, say, a 200-ish token size for chunks. What this does is it has the effect of keeping paragraphs together with some overlap at the chunk boundaries. This combined with techniques such as parent document or contextual retrieval could potentially work well if you're working with like mostly text data. Semantic chunking is another fascinating one for text where you try to find or align the chunk boundaries with the semantic boundaries of your text. And then there's semi-structured data, right? Which is data containing a combination of text, images, tables. And for that, I've seen folks retrieve the text and non-textual components using specialized tools. There's one called Unstructured that I particularly like. It supports a bunch of different formats and has different specialized models for extracting components present in different types of data. So yeah, I would use a tool like that. And then once you have those different components, maybe chunk the text as you would normally do. And then two ways to approach like the non-textual components. Like you either maybe summarize the images and tables to get everything in the text domain, or use multimodal embedding models to embed the non-text elements as is.
Yeah, definitely. Because if we take these documents and if we chunk them into too small of segments, the context may be lost, right? So
exactly.
And if you provide a prompt, the response may not be what exactly we're looking for. So
right.
So what are the other, especially if you're using a RAG-based application, which is probably the norm these days, for all the companies. I mean, they're all taking some kind of foundation model and ingesting, the company corporate data on top of that, right? So what are the other tech strategies are you seeing in the RAG applications in terms of retrieval or generation steps?
There's a lot of them coming every single day, but I can talk about the ones I've personally experimented with. So first one would be hybrid search. And this is where you combine the results from multiple different searches. It's commonly a combination of full text and vector search, but it doesn't have to be that. It could be vector and graph based, but general concept of that is that you're combining results from multiple different searches to get the benefits of both. So this is useful in, say, e-commerce applications, for example, where users might search for something very specific, right? Or include keywords in their natural language queries. For example, I'm looking for size 7 red Nike running shoes. So it's a natural language query, but it has like certain specific points of focus or keywords in them. So an embedding model might not capture all of these details. And this is where combining it with something like a full text search might make sense. Then there's parent document retrieval. And this is where you embed and store small chunks at storage and ingest time, but you fetch the full source document or larger chunks at retrieval time. And this has the effect of providing a more complete context to the LLM while generating responses. And this might be useful in cases such as legal case prep or like scientific research, documentation chatbots, where the context surrounding the user's question can result in more rounded responses. And finally, there's graph RAG that I've been hearing about a lot lately. And this is where you structure and store your data as a knowledge graph, where the nodes can be individual documents or chunks, and edges capture which nodes are related and what the relationship between the nodes is. And this is particularly common in specialized domains such as healthcare, finance, legal, or anywhere where multi-hop reasoning, or if you need to do some sort of root cause analysis or causal inference is required.
Yeah, definitely. The graph RAG has been getting a lot of attention lately. So
yeah,
especially with the power of knowledge graph and the RAG,
yeah,
the value, right? So yes. Okay.
But that's the thing, right? Like going back to what you said earlier on, like what's the hype versus what people should be hyped about? I think a lot of organizations have a hard time balancing that too, because like they want to be at the bleeding edge of building these applications, but then sometimes it might just be overkill to use the hottest technique.
So like where should the development teams kind of decide, hey, I started with the LLM based application in mind, but my requirements are not a good fit. So like what are those, I don't want to call them limitations, but what are the kind of boundaries where you say, for now, let's just go with the standard, solution rather than bringing some LLM and, to make it more complex, right?
I think this is not just an LLM thing, like even having spent like 6 years as a data scientist, right? Like a lot of times, like ML in general, since for the past decade or so, it's just been a buzzword. And sometimes people just want to use it for the sake of using it. So that's where I think you need to bring a data scientist or an expert into the room and be like, hey, this is my use case, and have them evaluate whether or not you even need to use machine learning, or in this case, like Gen AI for it, right? And going from traditional to Gen AI, now there's like a more of a preference to generative AI as well. So I think at this point, the decision is like, can I use a small language model or just use an XGBoost and get away with it? Or do I really need a RAG use case? But I think in general, if you want to like reason and answer questions using natural language on a repository of text, then I agree, like some sort of generative AI use case is important. But say you're basically just trying to do classification or just doing something like anomaly detection or regression, then just because an LLM can do it doesn't mean you should, because it might not be the most efficient thing at the end of the day.
So the traditional ML solutions are still, are relevant, right? So
yeah, for some things, yes.
Right.
But I think I do want to say, right, like the beauty of LLMs is that it's made machine learning approachable to everyone. Like it's not limited to data scientists anymore. A software engineer, a PM, someone who's not technical, they can just use these models without having to, fine tune or like worry about the weights of the model. And yeah, I think that results in these like pros and cons in a sense.
Yeah, you're right. So definitely these LLM models and these applications that use them have brought the value of these to the masses, right? So now anybody can use ChatGPT or Copilot and get the value out of this, right? So
Yeah.
can you recommend any like open source tools and frameworks for our audience to try out LLM applications if they want to learn about them before actually start using them?
Sure. Yeah. I'm trying to think what the easiest stack would be. So if you're looking at strictly open source, you don't want to like put down a credit card to just experiment and build a prototype, then I think three things, right? You first need a model of some sort, whether it's embedding or LLMs. For that, I would say use something like Hugging Face, pretty easy to get up and running with their APIs. You don't have to pay for it. Or if you want to go a bit deeper and try out something local, then Olama has support for a whole bunch of open source models. I like LangGraph for orchestration. It's something LangChain came up with a while ago. And a lot of people think it's an agent orchestration framework only, but I think, and I've personally used it for just building like control flows, or I think you could even build a RAG application by using LangGraph. It just gives you low-level control on the flow of your LLM application. For vector databases, if you're looking for something that's really quick and open source and easy to start with, then you could even start with something like Chroma or FAISS for experimentation. But of course, when you move from prototype to putting something in production, you'd want to consider enterprise grade databases such as my employer.
Yeah, definitely for local, just to get started, even the Postgres has a vector flavor of the database called PG vector, so there.
Right.
Then there's Quadrant and others, right? So yes.
Yeah.
So do you have any other metrics or benchmarks or resources that the teams can use to kind of look at, hey, I just want to see what are the like top 10 or top 5 LLMs, before I even start work on this?
There's an LM sys similar to what's the one you were mentioning?
The one I mentioned is Open LLM Leaderboard.
Okay. So there's a similar one on Hugging Face that I occasionally look at. It's called LMSys Chatbot Arena. And that's basically a crowdsourced list of evaluation of different proprietary and open source LLMs. And I think that's a good thing to look at than just performance on benchmarks, because like benchmarks can have data contamination. Sometimes vendors will actually train their models on benchmark data. So certain models could end up looking good on certain tasks than they actually are, which is why leaderboards such as the one you mentioned and LMSys are good, because it's actually people trying these models on real world prompts and tasks.
Yeah. Just like anything else, teams should try it out first and then see if it works for their use case and their requirements, right?
Yeah.
Other than that, any other additional resources on LLM application performance improvements and evaluation? Any online articles or publications?
I follow a couple of people and read their blogs. So there's this person called Eugene Yan. He's an applied scientist at Amazon. He has a blog and he's written extensively about evals and continues to do extensive research in that area. There's also a bunch of people in the machine learning community who had written almost like a white paper titled What We Learned from a Year of Building with LLM. So it's just like really technical practitioners who've written that white paper based on their experience building LLMs in the past year. And yeah, generally follow a mix of researchers and practitioners in the community.
Yeah, I think that's a really good discussion. So do you have any additional comments before we wrap up today's discussion?
I think, yeah, like our discussion made me realize just how important evaluation is when building just any software application, but LLM specifically, because while they've made ML accessible and usable in so many different domains, like what you really need on a day-to-day is for the model or application to perform on the use case or task you need. So I think evaluating for what you're building is key.
And also another key is your LLM mileage may vary, right? So it all depends on what you're trying to do and what are the constraints and the benchmarks that you are working towards.
Exactly.
Apoorva, thank you very much for joining this podcast. It's been great to discuss one of the very important topics in the AI space, how to evaluate the LLM applications, how to measure the performance, how to improve the performance, etc. So these are like practical topics that everybody is interested in, not just another hello world or ChatGPT tutorial, right? So thank you for listening to this podcast. If you like to learn more about AI and ML topics, check out the AI, ML, and data engineering community page on InfoQ.com website. I also encourage you to listen to the recent podcasts, especially the 2024 AI ML Trends Report we published last year, and also the 2024 Software Trends Report that we published just after the New Year's. Thank you very much. Thanks for your time. Thanks, Apoorva.
Yeah, thank you so much for having me.